Hey, AK again. In this video, we are trying to answer the question, is MATLAB programming easy to learn? My answer is a definite yes, and here are my reasons. It is easy to get started in MATLAB. You install MATLAB, you fire it up, and you're ready to go. And you can start solving problems right from the command line from the get-go. For example, let's say you have a quadratic equation 4x squared minus 25x plus 9 equals 0. You can solve this from the command line like so. You define a vector with the coefficients of the equation. Equation equals 4 minus 25, 9. And this command roots will actually give you the solution for this quadratic equation. All right, as simple as that. There is no need to install compilers or linkers to create executables. Neither is there a need for installing any additional libraries for performing floating point math or special libraries for trigonometric, logarithmic, or matrix operations. It's all part of standard MATLAB. Likewise, you don't need to install special libraries for plotting. The standard MATLAB installation comes with an extremely powerful plotting library pre-installed. You can do a lot of scientific and engineering modeling, do sophisticated analysis on your data, and produce professional grade plots very quickly. MATLAB is an interpreted language, and it is not a compiled language. This means when you press the run button, the MATLAB script is almost instantaneously executed. So if you just want to run the script, just press run, and that's it. There is no need to compile and link your code to create an executable. Okay, and the next point I want to make about the ease of learning MATLAB is that MATLAB code is very human readable. I would say MATLAB coding is it resembles mostly C programming in syntax, except for array indexing and indexing matrices, which can be a little bit tricky to begin with. Once you get past those hurdles, just reading MATLAB code and writing MATLAB code is very easy. Next on my list is the superb MATLAB Help system. You can type help on the command window, and MATLAB actually comes up with very good info on the syntax and suggestions for using MATLAB commands in practice. For example, if I want to get some more help on this command LSIM, which actually stands for linear simulation, just say help LSIM. It's very comprehensive help system. It actually tells you the input and output arguments, and it actually gives you the use cases. You can also go look at other commands that are in the same family, and you can actually look at the documentation for LSIM and other functions named LSIM, etc. So it's pretty comprehensive. In addition, you have the support system from the MathWorks, like the MATLAB Central. So you have the MATLAB Answers, the file exchange, where MATLAB practitioners actually upload complete examples. Some of these examples are really sophisticated. I have talked so far about the ease of using MATLAB. This does not mean MATLAB is a simplistic programming system. In fact, it is just the opposite. MATLAB is an extremely powerful scientific and engineering programming package. Even complex models and simulations can be created in MATLAB quickly and efficiently. I just want to show an example. All right, so you remember the fighter plane longitudinal dynamics from video 1. This is called the state vector. The state vector is the vector that has the variables of aerodynamic variables of interest. V is the forward airspeed, and alpha is the angle of attack, and Q is the pitch rate, and theta is the pitch angle. And these are all time differentials. This is the time derivative of the forward airspeed with respect to time, and this is again, so alpha dot is actually d alpha by dt, and this is dq by dt and d theta by dt. And this is given by this big matrix multiplied by the state vector itself, plus this matrix B matrix multiplied by the stimulus inputs. So this is what we call a matrix differential equation, and this is written in the form dx by dt, where x is a vector, equals A, this big matrix, multiplied by the state vector itself, plus B, this matrix, multiplied by the input stimulus vector. So the solution for this matrix differential equation is given by this cryptic looking equation, which is again a matrix equation because x is a vector, and remember A is a matrix and B is a matrix. So this is a fairly non-trivial problem to set up and analyze, but getting the solution in MATLAB, it is really easy. Let me just show you. Open fighter plane longitudinal dynamics.m, and these are the matrices that I talked about, A, B, and C, D matrices, and this is all plotting stuff. Just ignore the main stuff here. The gist of the solution actually happens in these two lines. That's it. You create the so-called state space system with these four matrices A, B, C, D, and this command, this innocuous looking command LSIM, which stands for linear sim, that actually solves this whole matrix differential equation. So this whole solution here is done by this single command here, LSIM. Let me just run this. That's it. Don't worry if you don't fully understand the math behind this. My intention was to show that relatively complex modeling tasks can be achieved, very easily in MATLAB, and I just wanted to show you the power and elegance of MATLAB. I hope this video was useful. Thanks for watching. I will see you in the next video.